solving a quadratic equation ax squared plus bx plus c is equal to 0 by completing the square and applying the square root property. But these are the 4 steps we have here. The first step is to make sure that the coefficient of x squared is equal to 1, because this method only works when the coefficient of x squared is equal to 1. Now, as I go through these steps here, I'm going to look at this example here and see how to solve this using this method. So I see 2 right in front of x squared. I need to eliminate that. Well, looks like if I divide this term by 2, I can accomplish that. I would get x squared. Now, I don't have any coefficient here. But when you do that, sometimes it creates fractions here, which is okay. Now, the coefficient of x is minus 5 over 2. And the constant became minus 7 over 2. Still, the next step is to move this constant to the other side, because I don't really need this constant. So I'm going to add whatever that number is, although it's a fraction, to the other side. I'm going to add 7/2 to both sides of the equation. I move it to the other side. I still need to add something to the left-hand side to complete the square. We take the coefficient of x, you divide it by 2, you multiply by 1/2, that's step number 3. And then you square that. You notice that you get fractions, which is okay again. 1/2 times minus 5/2 give you minus 5/4. If I square that, always becomes positive, you notice. Even if you have a negative number, it becomes positive. So you always add a positive number to both sides of the equation. It becomes 25 over 16. Rewrite the equation and then add both sides. Don't do this in your head. I was walking around the class and I see some of you kind of try to do some of this stuff in your head. Don't. Write everything down. Write the original equation, add the magic number, 25 over 16 to both sides of the equation. Now the left-hand side would becomes factorable, would becomes x, in this case minus, because the middle term is minus. Now this number always would be the square root of this number that you added, which is 5 over 4. Because 5 over 4 times 5 over 4 is 25 over 16. So here you would get x minus 5/4 times x minus 5/4. You can verify that by multiplying the 2 closest term and 2 furthest term, they add up to 5/2, which it does. Because 5/4 x plus 5/4 x. What is 5/4 x plus 5/4 x? What is 5/4 plus 5/4? We would do 5 plus 5, which is 10/4, right? Which is 10 over 4. What is 10 over 4 equal to? 5 over 2? Yeah, it's 5. Is that what you wanted the middle term to be? Yeah, exactly. We wanted to have 5 over 2x. That's exactly what we have here. See, 5 over 2x. So everything works. This time that the last term would be results in 25 over 16. So once you add this magic number to the both sides of the equation, the left-hand side becomes factorable. Not only factorable, also becomes perfectly squared. You get x minus 5/4 squared. Now, of course, you have to add what you have on the right-hand side. What's the LCD here? 16. So you have to multiply the first fraction by what? 8 over 8. So if I multiply this by 8 over 8, that's how you get that result. If I multiply this by 8 over 8, you get 7 times 8 plus 25, I give you 81. Everybody see that? So here I have it. I have something squared is equal to a constant. So what I'm gonna use? I'm gonna apply square root property. I would say x minus 5/4 now must be equal to plus and minus square root of this number. This is perfectly squared, so it would be plus and minus. What is square root of 81 over 16? 9 over 4, right there. So x would be equal to 5/4 plus and minus 9/4. So you get 2 solutions. 5/4 plus 9/4, which is 7/2. 5/4 minus 9/4, which is minus 1. So these are our answers. Okay, now is your turn to see if you can solve these 2 equations by completing the square method. You can go back and review the session on how to solve the equation using completing square. For those of you watching this right now, I would suggest you pause the session and see if you can get the same answer as we are going to get in a few minutes.
So step 1, you would add 4 to both sides, and you would divide everything by 7, and then you would multiply the 2/7 by 1/2 and square it. So you have 1 over 49. So you would add 1 over 49 to both sides, and then you would factor the left side, which would be x minus 1/7 squared. And on the right side, you have 28 over 49 plus 1 over 49. And then you would remove the square on the left side, so you have x minus 1/7 equals the square root of 29 over 49. And then you would move the 1/7 over to the right side, so you would have x equals 1 plus the square root of 29 over 7, or 1 minus the square root of 29 over 7.
Okay, so as you see here, we divide each term by 7. The first step is to move, like she said, -4 to the other side by adding 4 to both sides of the equation. Divide each term by 7. This method only works when the coefficient of x squared is equal to 1. So we need to find out what to add to each side of the equation here to the left-hand side in order to complete the square. The method is you take the coefficient of x, which is minus 2 over 7, and then you multiply by 1/2, or you divide it by 2, and you square them. So you minus 1 over 7, you square that, you get 1 over 49. You add 1 over 49 to both sides of the equation. The left-hand side not only become factorable, also would be a same binomial, because x minus 1/7 times x minus 1/7. So it would be x minus 1 over 7 square is equal to 29 over 49. Now we can use the square root property to solve for x. X minus 1 over 7 must be equal to plus and minus square root of 29 over 49. So I'm going to go ahead and solve for x by adding 1 over 7 to both sides of the equation. So x would be equal to 1 over 7 plus and minus square root of 29 over 7. At this point, you want to make sure that if it's reducible, you reduce them. It looks like these 3 terms are not a factor of a common numbers. So we're done. That would be our last step. So let's see. Somebody else wants to tell me what would be the steps for second part B? Go ahead and click on your mic and tell me the steps.
I'll do it.
Okay, good. Go on.
Okay, so you're going to subtract -1 on both sides, or add 2, either or subtract 2, which will get you, let's see, like we're ahead now. Okay, so that'll make that x in second minus -7/2 x plus 1/2. Well, I don't know what's going on here.
So it looks like the next step is to find what to add to left-hand side. Once you isolate, once you have the coefficient of x squared is equal to 1, like you did here, you want to know what to add to the left-hand side to complete the square. And you take the coefficient of x, which is minus 7/2, multiply by 1/2, and square it, and that's how we get this 49 over 16 to add to both sides of the equation, right? Is that what you mean? Okay. So what do you do after that? What do you do after that?
And all that. Then you would actually...
Can you factor this? Can you factor the left-hand side?
Yes, you can.
So you would factor it to what?
To, you factor it to...
X minus what?
X minus...
always square root of this number, which is 7/4.
7/4, yeah.
Yeah. Always becomes x minus 7/4.
Right.
So with this, if you factor this, you get x minus 7/4 times x minus 7/4. That's why we got x minus 7/4. Then you have to add these two, of course. Minus 1/2 plus 49 over 16. The LCD is 16, right?
Right.
You multiply the first fraction by
8.
8 over 8, and then you get minus 8 plus 49, you get 41 over 16. Everybody okay up to this point?
Mm-hmm.
Okay, now what do you do after that? What property are you going to use to solve for x? What's the name of the property? Do you remember the name of the property?
Can't recall.
No? Try again. Anybody in class? Square root, right? Square root property. Because you have to take a square root of both sides now, right? If I take a square root of both sides, then you get, what do you get? X minus 7 over 4 to the plus and minus square root of 41 over 16. So x would equal to 7/4 plus and minus square root of 41 over 4, which is square root of 16 is 4, right? You reduce them.
Mm-hmm.
So here we have it, 7 plus and minus square root of 41 over 4. You look at this carefully and see if you can reduce any of these. You look for common numbers among these three terms. Doesn't look like we have any. So we have 7 plus and minus radical 41 over 4. Any question on this? Anyone?